If there are no questions over the homework assignments, we'll go on and get started with today's lesson. Now, the first thing we're going to look at is midpoints and segment bisectors. Midpoint and segment bisector. The midpoint of a segment is the point that divides the segment into congruent segments. It divides it in half, is the midpoint. So if we look at this line here, M is the midpoint for the line because it's in the exact middle. And either side of it, AM and MB will be the exact same length and they will be congruent. Now, so that is midpoint. And segment bisector is a point line segment, or plane that intersects a segment at its midpoint. Because segment bisector, bisect. If you bisect, you cut it in half. So when we talk about a segment bisector, we're talking about a line that's being cut in half. We'll talk about angle bisectors, a line that's going to cut the angle in half. So when we see bisect in geometry, we're talking about a line, a point, a ray, a line segment, a plane that is cutting another figure or line in half. And we're mainly going to be talking about a line segment, not so much a line. Because a line extends indefinitely in two directions. So no matter how far it extends, since we don't know the ends, we can't figure out where the middle is. Because it's continuing on. Anytime we try to make a middle, it extends out further. And we don't know for sure if we actually got the exact middle. So most of the time we're talking about a line segment being cut in half. So we'll look at the first example problem here. In the skateboard diagram, WV, this line segment here, bisects XY, this line segment here, at point T. So it cuts it in half. And XT is 39.9 centimeters. We want to find the length of XY. So we want to find the length of the entire skateboard. Well, by our segment bisector, it tells us that XT is congruent to TY. Because point T is the midpoint. It cuts it in half. So what do I know about the distance from T to Y? What is it going to be? 39.9. Because those two lengths are going to be the same. It cut it in half. So the length of XY would be what? Well, 39.9 plus 39.9. We can add those two parts together to get the whole. So this here would tell me that XY is 8, carry the 1, 9, carry the 1. So it'd be 79.8 centimeters. 79.8 centimeters. Any questions on this here so far? We good with this problem here? Okay. So we want to find the length of PQ. Now they told us they identified the segment bisector of PQ because there is one. And what is the segment bisector of this here? Because it would be MN. And what would we draw above it? a ray starting at M and going to N. Because the segment bisector for this here is a ray, MN. It's what bisects it in half. It cuts the line in half, line segment. Well, P to M is 1 7/8. M to Q is what? 1 7/8, because if we know it's a segment bisector, it means it cuts it in half. It cuts it in exactly half. And again, we're wanting to find the length of the entire line. So what do we need to do? We need to add those two together. We need to add 1 7/8 plus 1 7/8. Now, if you want to plug this into a calculator, you can. But if we did this by hand, we can add the wholes together and the fractions together. So 1 plus 1 is 2. Now, since 7/8 and 7/8 do have the same denominator, we can add the numerators together. So 7 and 7 is 14. Well, we can't leave it like this because we need to reduce the 14/8. One thing I do know for sure is that we can pull an 8 out of 14 because it is bigger on top than it is on bottom. How many times can I pull 8 out of 14? Once, because 8 and then 16 is 2. So we can pull it out once, so we'd have 3. And what left over? 6. We can. Do 8 and 6 have a common factor? 2. So this would reduce to 3/4. And it does not give us a unit. So the entire line is 3 3/4 units. And that's it. Questions on this here? We good with this? Awesome. Do we need to see another example of one of these? No, we feel comfortable with this? Okay. Let's look at this next one. This here is the same exact concept of what we just did, except we're not given numbers. We're given equations, well, expressions for each one. What is the difference between an expression and an equation? Equals. We're setting two things equal to each other. It has an equal sign. Would be an equation. These are expressions. But we can still use what we know about midpoints to actually solve this. Because if, as it says, point M is the midpoint of line segment VW, find the length of VM. Well, if it's a midpoint, it means it cuts it in half. So it's telling us that VM and MW are congruent to each other. Yes? So what we could say, and what we can say, is that VM is equal to MW. That these two lengths are equal to each other. Since they're congruent, it means they have the same measure. Yes? Now, what is the measure of VM? 4x minus 1. Because we don't know what the actual number is, but we do know that this length is represented by 4x minus 1. MW is represented by 3x plus 3. So what we can do at this point is set this up and solve for the value of x. Because if I know what the value of x that makes these two equal, I can plug it back in to find out what the value is. So what we'll do is we'll find the value of x and then plug it back in to see what the length is. So what can we do first to solve for the value of x? So we need to get the like terms. We need to get x by itself. So how can we move x from one side to the other? I can subtract 3x from both sides. Because if I want to move something, move the whole thing from one side of the equation to the other, we either add it to both sides or subtract it from both sides. Because 3x minus 3x is 0. Over here, 4x minus 3x would be x. And now we would get to that by first adding 1 to both sides. Because negative 1 plus 1 is 0, leaving us with x is equal to 4. Is that what the question was asking for? No, but we had to do it to get to the answer. Now we just need to plug it back into one of the two equations. Do we need to plug it into 4x minus 1 or 3x plus 3? So let's plug it into 4x minus 1. So if I take this here and plug in 4, so we have 4 times 4 minus 1. 4 times 4 is 16. And 16 minus 1 is 15. So Vm is equal to 15. Now say I plugged it into the other one, 3 times 4 plus 3. So I use the other equation. Well, what is 3 times 4? 12 plus 3 is? Does it come as a surprise that we get 15 if I plug it into either one? They're both the same distance. Since they're equal, they should give us the same value. That's a good way to check to make sure that you got the right number. Because if it's any higher, any lower, that's not going to work out. So a lot of the stuff we do, especially with this here, we can plug the numbers in both sides to see, did I get it right? But some ways in mathematics, we do have ways to check our answers to make sure we got the right answer. And this here is one of them. Questions on this here? All right. Identify the line segment, or identify the section bisector of PQ. Then find MQ. So what is our segment bisector for this here? So we only have a point M, yes? So to name a line, we either need 2 points, so we would need point M and another point. Or there was another way to name a line. We'd say line L. Since they didn't give us 2 points, we have to look at the arrows to see if they gave us another way to name it. And they did. They gave us a lowercase l to name the line. So most likely, if you see a lowercase letter at the top or bottom of the arrow, that's going to be the way they might have you name the line if there are not 2 points. So line L is our segment bisector. Now again, if I want to find the length of MQ, I'm going to need to find the value of x so that I can plug it back in and see what the actual value is. Well, we do know the fact that point M is the midpoint, cutting this line segment in half. So it means for us that M or PM is equal to MQ. We don't know the exact value of each of these segments, line segments, but I do know that PM is represented by 5x minus 3, and MQ is represented by 11 minus 2x. Any questions on how we got this set up? So what can we do next? Yes, but not quite. Because this is what we're wanting to do. You're wanting to move the 2x exactly from the right side to the left. So we would add, we want to do the opposite. Is negative 2x plus 2x. These cancel out. That's what we wanted to have happen. We wanted those x's on the right to go away and move over to the left-hand side. Now 5x plus 2x is 7x minus 3 is equal to 11. Now what can we do next? Add 3. Is negative 3 plus 3 will cancel out, leaving us with 7x is equal to divide by 7, and exactly x is equal to 2. Any questions on how we found the value of x? We good with this here? So to finish this off, we still have to plug this back in. So I'll just pick 5 times 2 minus 3, or 5x minus 3. And 5 times 2 is 10. And 10 minus 3 is 7. So the length of MQ is 7. Because PM and MQ would both be 7. We put MQ mainly because that's what the question was asking for. But I would know what you meant. Because they both would be 7, so it really doesn't matter because both of these have a length of 7 units. Any questions on this here? Do we need to see another example of one of these? Do we feel comfortable with this here? Awesome. Let's look at the next piece of today's lesson. Midpoint formula. So the midpoint formula helps us find the exact middle of any line segment. Now it's a little bit easier if we were able to take a ruler and measure it and see what the middle is, but it's not always the case that it works out nicely. So this formula here helps us. Also, it's helpful with the fact that we don't actually have to graph it, because before coming across this here, if we wanted to find the midpoint of a line, we would either have to physically create the line to find it or have it actually there. So this here does help because we don't need to graph it. We don't need to use rulers. We don't need to use any tools to be able to find what the actual midpoint is. Now our midpoint formula is this right here. x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So let's look at some examples of finding the midpoint. Now here they tell us that the endpoints of line segment RS are 1, -3, and 4, 2. Find the coordinates of the midpoint M. So what we're looking for is point M. We want to look at the location of the midpoint. Well, our midpoint formula has two key parts. X1 plus X2 divided by 2, and Y1 plus Y2 divided by 2. So if I want to find the midpoint, we add the X values together and divide by 2. We take the Y values together and divide by 2. And that will give us the midpoint. So looking at the two endpoints, R and S, what are the X values of these 2 points? 1 and 4, because in any coordinate pair, it is always going to be X, Y, X, Y. So we have 1 plus 4. And the Y values would be -3 and 2. And again, when we plug these in for this formula, we're using the endpoints. We're not using the midpoint. We're just using the endpoints, X and Y value. Well, for X, 1 plus 4 is? And 5 divided by 2 is? 2.5. So the X value of the midpoint is 2.5. Now let's find the Y value. Well, -3 plus 2 is? And -1 divided by 2 is -0.5. Now we could rewrite this and say it is 5/2 comma -1/2. We could say that it's 2 and 1/2 comma -1/2. Any one of these three is the correct answer. It's just written in a different form. As long as it doesn't specify what form, I don't care what form you put it in. And I will take that, I will do that on any test. As long as it is the correct answer, I will take any form that you put it in. Okay? Unless it specifically states or specifies a form for the answer, rounding, if it's asking for rounded to the nearest decimal, you have to have it in decimal form. Questions on this here? All right, let's look at the next one. The endpoints of line segment AB are at A is 1, 2, and B is 7/8. Find the coordinates of the midpoint M. Find the coordinates of the midpoint M. Well, we know for the X values, we have X1 plus X2 divided by 2. And for our Y values, we have Y1 plus Y2 divided by 2. So what are our two X values for these points? 1 and 7, because those are the two X values of the M points. And the Y values are 2 and 8. And 1 plus 7 is? 8 divided by 2 is? 2 plus 8 is? Divided by 2 is? So the midpoint is 4, 5. How do we feel about midpoint? We feel good with midpoint? You just need to see another example of finding the midpoint given the two endpoints. We feel good with this here. We plug x's in, we plug y's in, simplify, and we are done. Using the midpoint formula. The midpoint of JK is M21. Okay, that's different. Why is that? So it already told us the midpoint, yes? So that means, well, my midpoint formula for the x's was that x1 plus x2 divided by 2. If I plug that in, I got the midpoint for the x value, yes? But they already told me what the x value of the midpoint is, and it is 2. So if I plug the two endpoints in, this here will equal 2, yes? And if we did the same thing for the y's, y1 plus y2 divided by 2, I would get 1. Because it already told me what the midpoint is. So most likely that means I'm going to find one of the other endpoints. One endpoint is J at 1, 4. Find the coordinates of the endpoint K. So, looking at our x values, I know what one of the x's is. It is 1, yes? So, one of the x's in the midpoint formula would be 1. Do we know what the other one is? No, we'll be able to figure it out, yeah. So we can call it x. Now for the y values, again, we do know one of them. One of them is 4. But we don't know what the other one is. We'll call it y. So we're going to have to do a little bit more work to find out what the other endpoint is, endpoint K. But the steps that we do to find it are going to be essentially the same thing. The first step in both cases, well, what we're going to do is try to get the variable by itself, yes? Now, when we do multi-step equations, and you've done multi-step equations before, we always try to do it addition and subtraction first, multiplication and division next, and then go in that order, really powers and working, so on. But when we look at this here, what is the big thing? It's everything is being divided by 2, yes? The 2 is on bottom. Let's undo that first. So I'm going to write this out for the first step, and we won't see this later on. Because when I multiply a fraction by a number, we multiply, so am I going to multiply the 2 by the numerator, the denominator, or both? The numerator. Whenever we multiply a number by a fraction is always the numerator. Because more or less what we're saying is 2 over 1. So we multiply the numerator by 2. So we'll have 2 times 1 plus x divided by 2. On the other side, 2 times 2 is 4. Well, anything divided by itself is 1. So these 2's simplify to 1, leaving us with 1 plus x is equal to 4. I always want to write this out at least once so that y'all see it. Y'all seen this before and done this before, but I just want to make sure it's still there and y'all still remember it. So last but not least, we would subtract 1 from both sides. which will tell us x is equal to 3. Now, I wouldn't subtract x from both sides because all the variables x are already on the same side and they're already over there, yes? So I wouldn't want to mess with moving x. Is it wrong to move x? No. But it would require a few more steps. Because whenever the variable is already all on the same side, let's move everything else away from it. So the x value of our endpoint k is 3. Now we need to do the similar thing for y. Well, what was our first step for solving for the value of x? We multiplied both sides by 2. Over here, hey, it's being divided by 2, isn't it? Why not do the same thing? Because as we saw with x, these 2's cancel out. They become 1. That's why we're multiplying both sides by 2, to get that division to go away. And that leaves us with what? 4 plus y is equal to 1. And then what do we do? Subtract the 4 from both sides, which tells us y is equal to -3. So our endpoint is 3, -3. Now again, when we started this problem, I said it's going to be almost the exact same thing for this here for both sides. We multiplied both sides by 2, got the variable by itself. Now getting the variable by itself might be different because we might be adding or subtracting depending on the number. But the first step is always going to stay the same. We're going to multiply both sides by 2 once we get this set up. Any questions on this here? Awesome. You hopefully turn the page. Let's look at another one. In years past, this has been one of the ones that some of the students have had trouble or struggled with, is getting this straight. So I think, because y'all seem to be picking this up pretty well, but again, it's not giving us the 2 endpoints, it's giving us a midpoint and an endpoint. And we want to find the other endpoint. So really what we should be doing is sticking with our formulas. x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Now it already gave us the midpoint m, which is 2, 4. So let's plug that in. So if the x value of the midpoint is 2, that means that this here is going to equal 2. And it tells us that the y value of the midpoint is 4, so this here should be equal to 4. We plug those in. Now it also told us an endpoint is at 1, 1, so we could plug that in. We have 1 plus x divided by 2 is equal to 2. And here we're going to have 1 plus y divided by 2 is equal to 4. Y'all want to solve for x first or y first? We can do x. It really doesn't matter. We're going to have to solve for both. So what would we do first? Multiply both sides by 2. And the reason we multiply both sides by 2 is because we want this division of 2 to cancel, leaving us with 1 plus x is equal to 4. And then we would Subtract 1 from both sides, telling us x is equal to 3. All right, so what can we do here? Multiply both sides by 2, because we want those 2's to cancel, which leaves us with 1 plus y is equal to, and again we would, telling us that y is equal to u. So the midpoint u is, well, we wouldn't use an equal sign. It would just be 3, 7. So how do we feel about this here? Not that bad? Because as long as we stick with the midpoint formula and remember where we need to plug each thing in, these are not that bad. And that's the key thing, is remembering where we're plugging stuff in. Well, if we feel comfortable with that, let's move on to the next thing. And the next part is the distance formula. Okay. Now, the reason that the distance formula is nice is because we can now find the distance between 2 points that are not along a straight line. That's what made last night's homework kind of nice, because since it's on a straight line, we can just count the units as long as we keep those markers evenly spaced. We don't have to use a formula to find it. Will the distance formula work on a straight line going north, horizontal or vertical? Well, yes. But it works very well on lines that are not horizontal or vertical. It works on any of them. And that's what's helpful. We also don't have to graph it to be able to find the distance. We can just use this formula. And the way they actually got this formula is from the Pythagorean theorem. Because what does that shape there make? A right triangle, yes? A squared plus b squared equals c squared. So if I called this a, b, and c, a squared plus b squared equals c squared, this line. Well, if I square root both sides, the square root of c squared is just c, leaving us with a squared plus b squared. That's just the Pythagorean theorem. Would you all agree with that? Now, our ruler postulate, which we learned yesterday, or saw yesterday, said if I took the two values, or the spots on the line that have a value, and subtract them, I will find their distance. Well, the x values, I take them and subtract them from each other, I'll find the distance of that line, x2 minus x1. If I subtract the values of the y, I will find that distance. That's where we get the x2 minus x1 squared plus y2 minus y1 squared. Distance. Now, with the distance formula, where we place x and y doesn't matter. As long as the x's are in the same set of parentheses and the y's are in the same set of parentheses. When we start talking about slope, y2 minus y1 over x2 minus x1, the order in which we put x and y in there matters. Here, it does not. Mainly because of the squares, the fact that we're squaring each set of parentheses. Because if we square a negative number, a negative times a negative is a positive. A positive times a positive is a positive. It'd be a positive also. Okay? Well, we'll stop here for today, mainly because I believe we're about to run out of time, but we'll pick this up on Monday.